So I'm Tim Bannister. This talk is about the blackboard pattern in Kubernetes. It's the last talk of the day, so we're going to wrap up after this, but it's the last of the session talks. Let's run with some audience interaction. So, for you folks, what's an example of the blackboard pattern outside of Kubernetes? Anyone? Sorry, and what was that? LLMs? I'm not sure that LLMs like that's more of a transformer typically. Anyone else? Anyone else want to call out? Whitney?
World War II, aircraft tracking.
Air defense, you say? Okay. And why did you choose that?
Okay.
Why did you choose air defense?
Oh, because you and I, because you told me beforehand.
Yeah, okay.
Because we made a thing together.
We did. And I'd like to thank Whitney very much for helping me make the slides here. So I'm going to talk about blackboards. I'm going to talk about getting to Kubernetes. But before we get to Kubernetes, it's the middle of the 20th century. World War II is over. And yet a Cold War is just starting. The superpowers fear air attack. It's never been more crucial to tell if we're at peace or at war. Starting from like the mid-1950s, air forces, especially in the West, spent huge amounts of money, resources, on equipment and technology for air defense. Huge radar installations and information systems as well. Because this is where hypertext comes from. It's where mice come from and the internet. But before that, they had blackboards. And they had lightboards, which is where the writing shows up bright. So I'm talking about air defense because it's really different from Kubernetes. But there is a common pattern. Imagine we're in a radar room. Somewhere buried under the surface of Scotland, people are earnestly making sure that the country is safe. Information comes in. We've got unidentified contacts. There's 3 blips over the North Sea. And they're moving west. And back then, before they had the computers, they'd get a little bit of like a China graph or something and write it up. There's people in this room, in this bunker, looking around, trying to figure out what's going on, trying to figure out if they're safe. And they write information on the blackboard. We'll give them an ID. We don't know what these contacts are, but now we can identify them. We're currently okay with the events that are unfolding. But let's put some more information on our blackboard. So these contacts, they seem to be Russian bombers. In the Cold War, this would be bad news, but it's important news too. So military people call this a recognized air picture. Different people with different roles can see a consistent view. They don't have to explain it in words to each other before they ask questions about, how do we know these are Russians? There's no time for that. And the technique came from the 1930s of the Royal Air Force in the United Kingdom, but it was adopted worldwide. They switched from lightboards to technology. Maybe some of you are wondering, like, okay, this is air defense. Like, what's the link to the cloud? There's one easy segue. I mentioned the internet. The need to connect all of these systems together directly led to the invention of TCP/IP, which kind of important. But there is something else. It's the blackboard architectural pattern. Now, there's 3 components in a blackboard, which I'm going to explain in reverse order. Controllers, briefly. Now, give me a hands up if you know what controllers are in Kubernetes. Okay, yeah, good. We've got some folks who've heard of these things. So controllers, they act on what they know about your cluster to drive it, the actual state towards the drive the actual state towards the desired state. And the blackboard pattern, before Kubernetes was a thing, was already talking about this. In Kubernetes, we have controllers and we have operators. And I mentioned operators because of the heritage, the etymology. We call them operators because they're like the people who loaded the tapes in your data center or fixed your web app at 3 a.m. The operator pattern is about making automation that does as good a job as the person who deploys your app. Well, controllers were originally the people who looked at the blackboard and did things. But they're also the people who maintain the blackboard. So in this pattern, controllers write to the blackboard, read from the blackboard. They are processes, they're not people. They're processes that manage knowledge on the blackboard. Controllers are the way that knowledge gets added, and different controllers react in different ways, depending on what they see. So I hope some of you are starting to see the parallels with Kubernetes. In your cluster, maybe you've got a cron drop controller. Probably not going to pass conformance if you don't. And it's watching the blackboard. It's watching the blackboard to see what happens to jobs, but also when the cron job controller makes a job, well, it writes to the blackboard, other things write back, it sees what happened. And the kubelet watches the same blackboard to find out what blobs to run. And I'm kind of labouring this point because I want to make it clear that it's true in air defence too. You didn't just have one controller, you had different jobs. One controller might scrabble fighters, and another one might notify fire stations. And in the pattern, that's called knowledge. What do we know? We put it on the blackboard. There's distillation of knowledge. So however it's represented, this isn't a fire hose of every fact we know. It's not all of the radar data or all of the sample data for audio recognition. It's distilled based on the raw events that are coming in. Same in Kubernetes. It's not every single byte coming down from the kubelet. Controllers make sense of what they learn, and they share a relevant summary. And blackboards hold knowledge. They're durable. Controllers are what put the information on the blackboard and remove it. If you've got a blackboard and the information is disappearing for some other reason, that's a bug, that's a fault. The blackboard doesn't expire anything, it's done. And the source of truth can be external, often is. So Kubernetes API server, it is the blackboard. I guess some of you are way ahead of me, that's what I wanted. Kubernetes, yes, it's a REST-like API, but actually the HTTP part is not the important detail in this architecture. We've got these qualities of the blackboard. It's got heterogeneous components, different things are looking at it. The data store is completely separate from controllers, at least logically. And the whole architecture has a tolerance for partial knowledge. It's not built around that. And actually, this place where I've got to in the talk, I just wanted to set that background for the kind of my real point, because my real point is about security. How do you secure this? For air defense, there's a trusted boundary, the building perimeter. You've got people whose job it is to make sure that everyone inside that boundary is authorized. And I guess, to stretch the analogy a little, unreliable controllers are terminated and replaced, and possibly there's a court-martial. So this talk is really about the secure blackboard pattern. Would anyone like to give an example of a secure blackboard? And I asked that question to make a little point. There is this architectural pattern, and it's established. You can look up the papers and so on. But there's very few examples of it, except there's this thing that at this KCD UK, we're all about Kubernetes. And so Kubernetes is this almost unusual example of this architectural pattern that's really powerful and hardly ever used. So that's my thesis. There's some more components to a secure blackboard. Adding security means we now have 5 elements to think about. And I say 5. I hope you thought about audit logs. A secure cluster kind of depends on being able to audit what's happened as well. And I'm going to talk about these extra details. Even if you trust all of the controllers and components, you might not. Kubernetes has clients, and they can write to the blackboard too. That's how you interact with Kubernetes. And we can't control what they want to do. But we can restrict what they can do, and that is essential. So In the pattern, a secure blackboard needs a way to limit who can write where, who can do what. And if you're in the talk, I bet you can guess what I'm going to tell you. Kubernetes provides namespaces. Those are your primary isolation boundaries. It's as if you've taken a real blackboard and you've pulled down a blind and said, you can't see that, you can't write to that. And a bunch of you will know as well that out of the box, vanilla Kubernetes makes security bypasses a bit too easy. But because we've got those isolation boundaries and we've got other details, the ingredients are there for locking it down. So another aspect of Kubernetes security is about making sure that principles, fancy word for users and groups, but principles are kept apart, and Kubernetes gives you the building blocks for this. You can grant access to a specific API, like job. You can grant access to specific resources, like this particular cron job. And in really recent Kubernetes, you can even grant access based on, does the thing have a particular value in a particular field? So the out-of-box controls might not be enough, but the ingredients are there. So authentication and requiring authentication, it kind of means you can trust your audit logs as well. And if you go and look at what this architectural pattern means, if any of you have having gone to this don't trust me and go and read the paper, you'll see that audit logs are a sort of a key element of the pattern. And if you can't trust your audit logs, you definitely have a problem. I guess this is where I mentioned that I work for a security company, and if you have that problem, do come and talk to us. So this is what the control plane looks like in terms of the containers and processes you need to run. That's the most common diagram of a Kubernetes cluster. And you add some nodes, and you add some add-ons, put your own controllers in there, and you start building a slick cloud platform. Great. Kubernetes architecture kind of follows its own design principles. It's self-consistent. And what I mean is, like, the API server doesn't specially trust other things. It doesn't trust the nodes. It doesn't trust other controllers to be doing a good job, any more than it has to. I'd give you an example. Like, the scheduler can have a look at nodes. It can see all the nodes. It can query infrastructure resources, look at pods. You shouldn't give it access to anything else. And typically you don't. But actually, this picture is not what I want you to leave here thinking about. So here's a cron job in a namespace. This could be a view on a blackboard. I was saying those air defense controllers, they didn't see everything on their screen. They had a view on what they needed to see for their job. When you've got that, like, one controller, air defense controller, might not see that there's cities on the map. They don't need to see where the cities are for their job, but the system knows. We can draw what's important on the blackboard. We can make views, we can filter, and we can restrict access so that people really can't see further. Crucially, and you'll know this, but I want to link it to the pattern, nothing in Kubernetes, nothing in this pattern depends on one element having access to the entire blackboard contents. I'm also going to go back to, I think Anna's in this talk. So we opened this yesterday with Anna's talk on what Kubernetes is, and I'm just going to borrow this slide with her permission. So she was talking about a workplace and Kubernetes being different people and communication tools for business. I think this is a great analogy. I really like it. But to link it to my talk, just imagine that the blackboard is what all these people are looking at. So I'm going to recap. The secure blackboard pattern has 5 elements, and my thesis is that Kubernetes is actually the best known and best example of that pattern. Kubernetes is much more than a blackboard. The security primitives and extension points let you, and the control plane working for you, make a secure, auditable, resilient blackboard for orchestrating your cloud-native workload. And it's also the Achilles heel. You've got these APIs, you've got certificate signing request, you've got role, cluster role binding. They're all written to the blackboard. So with this pattern, it's not like the analogy of like an American air defense center circa 1969. Because there, you didn't use the radar screens to decide who can access the building. But with Kubernetes, the blackboard is your security boundary, and securing it becomes incredibly important. And making sure that security is built into your platform is essential for success. And really, that is my point. Kubernetes is the secure blackboard pattern. This is how I recommend people think about their cluster, think about what a Kubernetes is when you're modeling the security properties of it, because the strengths and the weaknesses fit that analogy really well. Thank you for listening, folks, and perhaps we've got some time for questions.